Believe it or not, you are actually at the last video of this unit. So a very short unit. Make sure you go back and watch any videos you need to rewatch. It's a little bit of a complicated unit, so make sure you do that if you need to. So we're going to look at drawing conclusions and the chain rule. This drawing conclusions part is extremely important. It's going to come up again when we get to proofs in a couple chapters. Proofs, if you can do these conclusions, proofs are going to be a lot easier on you. So it's good if you guys can get a handle of it. Now, so what we have to do is look at a diagram and make a conclusion. Okay, you don't need to tell me what's going on in the diagram. You need to look at the conclusion, or look at the diagram and come up with some sort of a conclusion. So, in number one, I'm given this diagram. I need to come up with a conclusion, and I have to be able to back it up. You always have to support what you're doing. So, if I look at this, we would say that, okay, we have ABC as an angle. We have angles ABD, we have angles CBD, or angle 1 and 2, whatever you want to call them. So, this goes off of what you've already learned. Things you've already learned. I'm not going to throw anything different at you. What we could say is, we know that these two little angles add up to be the big angle. So our conclusion would be angle 1 plus angle 2 is congruent to angle ABC. The reason behind that would be our angle addition postulate. That was the official name of it before. You're not going to see little plus little equals big on a test. It's the angle addition postulate. If you add them up, it equals the big angle. If we look at another example, okay, given x is the midpoint of AB. Okay, so draw a picture if you don't already have one. Sometimes you'll need to draw one. So x is the midpoint of AB. Our conclusion then, okay, what can you decide based on that? Don't tell me that x is the midpoint of AB. That's a given. It can't be the same as your given. You have to come up with something different based on that picture. Well, we know that x splits this in half. It cuts it directly in half. Therefore, we know that AX, line segment AX, is congruent to line segment XB. Reason behind that is, technically, we would call that definition of a midpoint, or you could say something like midpoint cuts a segment in half, something along those lines. I'm going to do maybe one more. Let's see how many we have left. Maybe we'll do two more with you, and then I'm going to let you guys try the rest to finish for homework for tomorrow. Given this diagram, conclusion, okay, well, again, don't tell me that you know they're right angles. It's already labeled that they're right angles. We don't need to know that they're right angles. It's showing me that. But can you come up with something else based on that? What do we know about right angles? Well, if we know this is a right angle, we know this is a right angle. We know that angle A is congruent to angle C. The reason behind that would be that all right angles are congruent. Pretty obvious. If one's a right angle, the other one's a right angle, they have to be equal to each other, or what we would call congruent. Last one. Okay, this one you guys should know. Given that diagram, what do we know about angle 1 and angle 3? Don't tell me that they're intersecting lines. We need more than that. We're looking for, we know angle 1 is congruent to angle 3. The reason we know that is because vertical angles are always congruent. That was actually a test question on the Unit 1 test. Okay. So again, look at the diagram and come up with something that you can infer based on what's happening. I'd like you guys to try 5, 6, 7, and 8. So all of these come with conclusions and reasons for tomorrow. Last thing we're going to look at, last thing of the entire unit, chain rule. I actually think this is one of the more fun pieces. I actually remember taking or answering a question like this on the ACT. So I think they're kind of cool. Maybe you'll agree with me, maybe not. But sometimes in mathematics we are able to use logic to draw more conclusions than you would have originally assumed. We do this by forming a chain of conditional statements. This method is called the chain rule. You use the chain rule in your everyday life too. Here's an example. Mike is taller than Lisa. Lisa is taller than Susie. Therefore, we can conclude that Mike is taller than Susie. Again, it's kind of like the syllogism where we have that connecting piece. We can conclude that Mike is taller than Susie. Some of you sports fans may think like the Bears are better than the Packers beat the Vikings, therefore the Bears are better than the Packers and the Vikings. Okay, so it doesn't really work like that necessarily, but that's what you can conclude based on certain situations. So, if we look at an example like X then Y, we can also say that if not Y, then not X. Remember, this little tilde makes it not. So you're using the contrapositive of the conditional. Okay, so in this case, we would say if Susie is not taller than Mike. Okay, so that's what we would say in that one. Or if not C, then we would have not D is to C. You're switching, so we already had a not in C, so we're going to take that not away. We didn't have a not in D, so we're going to give it to that D. Okay, remember, we get the contrapositive by switching and negating the phrase. So you flip the hypothesis and conclusion, and you negate the phrase. You do both things. So if we look at a couple of examples here, the way I'll teach you this is a pretty simple idea. We have three different statements in number one. If A, then B. If X, then J. If B, then X. With this, please circle the letters that only appear once. A and J only appear once. You're going to use the other pieces for connecting pieces. So you're going to start your statement by saying, always go with the letter that's lower in the alphabet, just so you can go in alphabetical order. If A, then B. Okay, so you use that one. Now look for the connecting piece. Okay, we have B, so use this B as your connecting piece. So our next statement is going to be if B, then X. That one's done. Last one, make sure you have your connecting piece, but it's going to be if X, then J. So between all these, you have connecting pieces. Connecting pieces. Therefore, we can conclude that if A, then J, and that would be our conclusion. If we look at number 2, if A, then not J, if R, then M, if not R, then J. Again, please circle the letters that only come up one time. So we have A that comes up once, M that comes up once. Those are going to be our starting points and our ending points. Start with your starting point and make it if A, then not J. Leave it just like that. We've used that one. So we need our new starting piece to be if not J. So we're looking for this not J. We don't have it. However, we do have this J down here that we could turn into a contrapositive statement, meaning that we're actually going to get rid of this and make it if not J, then R. We're using that contrapositive, switching that conditional statement. So what it's going to say now is we can use that as our connecting piece. So it's going to become not J, then R. Okay. The next one, so we've already used this one. There's only one statement left, and it's already using R as its connecting piece, so it would be if R, then M. There's your connecting piece. Therefore, we know that if A, then M. Okay. I'm going to do one more with you guys, and I'm going to let you guys try number 4 for homework. If you want to skip ahead and try 3 without me, that's fine too. Okay, again, circle the letters that only appear once. A comes up one time, and R comes up one time. So let's start with A. So we're going to say if A, then M. Okay, start there. Now we're looking for the next one. We need a connecting piece, so we need it to be M. We have it here, so we can leave it if M, then not C. Now we're looking for a not C. I don't see that, but I do see a C in that second one. So what I can do, again, is get rid of this and make it, if not C, then D. We're using the contrapositive. Switching and negating. D already had a not, so you're going to take it away. It's like a double negative, becomes a positive, and C now has a not. So you can use if not C, then D. Now you've used this one, and then your last one you need to find is if not R, then not D. Okay, we need this to be a D in this area here. So I see my one statement that I have left, I haven't used. I know I have to finish with that R. Again, I can rewrite that as if D, then R. Both of them were already negated, so you're negating a negation, which is going to be like a double negative again. So it's going to make it if D, then R. They're flip-flopped, and they have both been negated. So there's your connecting pieces. You should always double check and make sure that you have this chain where everything's following in sequential order. If A, then M. If M, then not C. If not C, then D. If D, then R. Therefore, our conclusion is if A, then R. Okay. I want you guys to try 4. I'm going to do one of these last examples, and then I'm going to want you guys to try this example down here. We might even do that one in class. So, if you are a Butler fan, then you wear blue. If your math teacher went to BU, then his name is Mr. Matheson. If your name is Mr. Matheson, then you are a Butler fan. Okay, so you're looking for what comes up only one time. So let's go through this. Remember, you're not looking, you have a bunch of different statements. You have your hypothesis, your conclusion, your hypothesis, your conclusion, your hypothesis, conclusion. You're looking for the hypothesis and conclusions that only come up once. So if you look at it, if you are a Butler fan, that comes up. Does it come up anywhere else? It comes up here. It comes up here. So that's not what we're going to use to start off with. Looking at the second one, you wear blue. Okay, I see it one time, I don't see it again. So I know that I'm going to be needing that at some point. If your math teacher went to BU, if we look at that, does that come up again? I don't see it. Okay, keep going. His name is Mr. Matheson. I see it here. I see it here. Okay, so we need to use the two pieces that I didn't highlight, that you wear blue, and if your math teacher went to BU or Butler, we need to use those as our starting piece and our ending piece. Always start with the hypothesis. So what we'll say here is if your math teacher went to BU, then his name is Mr. Matheson. Okay, so there's our first one. Okay, that one's done. We've used it. Now we need that connecting piece. Okay, match the green up with the green. So we're going to go with that one, and we're going to say if your name is Mr. Matheson, then you are a Butler fan. Okay? Use that one down. Just make sure you connect your blue with your blue on the tops. And then we're going to say if you are a Butler fan, then you wear blue. Okay, so again, use the circling, underlining, the highlighting. You can use a highlighter on the test if you want to figure out the order of these. It's not just going to always be in a straight order, the top sentence, the middle sentence, and then the third sentence. So you have to be very careful with them. I'd like you guys to try number, or not number, I guess this last one that I've starred with the yellow highlighter, I'd like you to try and at least identify what's only being used once, try and get in the right order. In this case, you have 4 different sentences. See if you can come up with that and bring it to class tomorrow. See you guys.